Hello everyone, my name is Manavar, and in this video I'm going to talk about the analysis of influenza season in USA. You are probably wondering why is it so important to analyze it? Well, soon I will answer you with some impressive statistics which speak for themselves. Every year USA suffers from the surge of influenza cases, which lead to overcrowding of hospitals with patients who suffer from the flu and develop serious complications. In order to provide adequate treatment to these patients, hospitals need additional medical staff, which are provided by medical agency. And it is crucial to efficiently allocate this additional medical staff across US states. Otherwise, the situation will get out of control and there will be serious consequences in the form of increase in the number of lethal outcomes. So now let me highlight these outcomes. The bar chart here on the left represents the number of people dying from flu each year in USA. And you can see that for the years 2015 and 2017, it is really close to 80,000 people a year. And this number could increase if we don't plan the efficient allocation of medical staff. So the objective of this analysis is to determine when to send staff and how many to each state. The agency covers all hospitals in each of the 50 states of the United States, and the project will plan for the upcoming influenza season. For this analysis, I've used the data provided by US Census Bureau and Center for Disease Control and Prevention. Now, let me inform you about the summary of findings. Influenza season reached its peak during December-March, and the most vulnerable population is adults aged 65 and over. Here you can see the decomposition of flu deaths by age groups, and you can notice that around 60% of flu deaths are among people aged 65 and over. And here you can select a specific year in the bar chart and analyze the change in the composition over the years. And you can notice that there isn't any drastic change. Over the years, around 60% of flu deaths are among the people aged 65 and over. So the allocation of medical staff will be conducted based on this finding. Now, let's discuss each finding in detail and start with influenza seasonality. So when does influenza reach its peak? Let's analyze the radial bubble chart here. It has the line of bubbles which represents the months. For example, here is December, January, February, and etc. The color of bubbles indicates season. Blue is for winter, pink is for spring, and etc. And you can hover over the bubble to investigate in detail the number of deaths in a specific month of a specific year. The years are sorted in ascending format, and the innermost circle is for the year 2009, while the outermost circle is for the year 2017. Here, the first thing you can notice is the size of the bubbles. They get a lot bigger during winter and beginning of spring. Why is this? It's because the size of the bubble corresponds to the number of deaths. So the number of deaths as influenza season starts from December, reaches its peak at January, and starts and ends by the end of March. Now that we have determined the influenza seasonality, let's look at the line chart, which is on the left side, and it forecasts monthly influenza deaths for 2018. And you can see the similar picture. The 2018 influenza season is expected to start from December, reach its peak in January, and end by the end of March. Now that we have determined the influenza seasonality, let's see who are the most vulnerable population. On the right side here you can see the column bar, which represents the flu mortality rates in USA by age groups during 2009 to 2017. And you can clearly see that the number of deaths start to double starting from population over 65, and it is at its highest among population over 85. And you can analyze this information in more detail by selecting specific year and specific state, but the picture here doesn't really change. The population aged 65 and over are the vulnerable population. In fact, I have also performed a t-test in order to analyze this hypothesis. The hypothesis that states that population aged over 65 and are under higher risk of dying from flu. And now I can say with 99% confidence that population over 65 are under higher risk of dying from flu. If you are interested in details of the t-test, you are free to contact me by email. Now we can proceed to the scatter plots here. The first one here represents the relationship between the total number of people over 65 and total death numbers. We can see a strong positive correlation here. And before you ask me what is the correlation, simply stated, correlation is a statistics that measures the degree to which two variables move in relation to each other. It is expressed numerically by correlation coefficient, and its value can fall between -1 and +1. Here we have correlation coefficient of 0.94, which is a strong positive correlation. What does it mean? It means that as the size of the population over 65 rises, the number of deaths will also rise. And if we look at the relationship between proportion of people over 65 to population and death ratio, we can see that there is a really weak or close to no correlation in here, with correlation coefficient of 0.1. It means that it is not recommended to target the states with the highest ratio of people over 65, since they are not correlated with the death numbers. It's because some states like Alaska have the lowest ratio of vulnerable population, but their death ratio is among the highest. The best strategy would be to target states with the higher size of vulnerable population and states with the highest death to population ratio. Now, let's discuss which states are at a higher risk. The map here illustrates two things: the death numbers, which are illustrated by the shade of the area. The darkest shade represents the highest death numbers, while the lighter shades represents smaller death numbers. And the bubbles here correspond to the size of the population over 65. And the bigger the size of the bubble, the higher the number of population over 65. We can see a pattern here. For example, we can see that the states with higher number of people over 65 also have the higher number of deaths from flu. Here, California has a high number of deaths and high number of people over 65. Also, Texas, Florida, and other states. While Alaska, who has a small number of people over 65, has also the small number of deaths, which is also in Montana, North Dakota, and other states. However, if we put aside the population size, we can see that, for example, 2017, the death burden, which is a calculation of how many people per 10,000 die from flu, is the highest in Alaska, who in this map had the smallest number of deaths. And California, who has the highest number of deaths, has only 60 deaths per 10,000. This case clearly illustrates that we should not only base our assumptions on the size of vulnerable population. We should also account for the death burden. Now, on to recommendations. 2018 influenza season, as it was the case with other influenza seasons, will be at its peak during December-March. Therefore, the additional staff should be sent no later than the beginning of December. Medical staff should be allocated in accordance with two factors: size of vulnerable population and death burden, proportion of the number of deaths to population size. The map on the left here represents the recommended allocation of additional medical staff in percentages. The calculations on allocation of medical staff were made taking into account both the size of the vulnerable population and the death ratio. And the light shaded areas here require fewer additional staff, while the darker shaded areas require more additional medical staff. For example, California here requires about 6% of additional staff because of its population size, while its death ratio is around 0%. And here Alaska, whose death ratio is amongst the highest, 2%, requires only 2% of staff because the population size is a lot smaller than California. But it also requires more additional staff than states like Nevada, Oregon, Iowa, and other states who have a bigger population because of its death ratio. So this map of efficient allocation of medical staff accounts for both the size of vulnerable population and death ratio. Data limitations. The decanical census is collected only once in 10 years, so the annual data is estimated using other sources, which could result in some discrepancies. The number of deaths up to 10 were registered as suppressed, and for the sake of analysis, they were replaced by 5, so death statistics could be slightly over or underestimated. We could further analyze other factors like vaccination rates, but for now, this analysis has come to an end. So thank you for your time, and feel free to contact me if you have any other questions regarding this analysis.